to this video session. I remain Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall continue our study on modular arithmetic and algorithms. In this video, we shall calculate the GCD, greatest common divisor, and the least common multiple, LCM, of two numbers, and also of an array of numbers, not just two numbers, more than two numbers, using the prime factorization method. Please, before you view this video, it is highly recommended, I've said it 3 times, that you view the videos in order. It's a video playlist on my website. It's a video playlist. You view those videos in order. Okay, don't skip anyone. We mentioned in the video on a GCD introduction and concepts, we mentioned 3 methods. 3 methods of calculating the GCD of two numbers. We mentioned listing method. You can also do the LCM by listing method. So we explained it in that video. The second method we mentioned is the prime factorization method. Okay, and the third method is the Euclidean algorithm method. Okay, we also have the fourth method, if you want to, the extended Euclidean algorithm method. So this video we are discussing the third method, prime factorization method. Like I said in that video, okay, GCD introduction and concepts video, listing method, you can, if you have big numbers, it is not good to, it will be cumbersome using the listing method. Okay, the method I used there. If you have big numbers, and somebody asked me a question in the comments, and I responded. So we are going to solve that question in this video, that particular question. So I will solve the questions we've solved with the Euclidean algorithm. We shall also solve it in this video, but we are going to use prime factorization method, and it will give us the same answer. Now, why I also like this, you know why I like this? You can use it to find the GCD of an array, like of more than 2 numbers. If you have 3 numbers, 4 numbers, 5 numbers, and you want to find the GCD, it mustn't be only 2 numbers. Okay, then this method you can use it, and it works well. The notes, the videos, the links to the videos, and the calculator for modular arithmetic and algorithm is this website. Okay, www.modular-arithmetic.appspot.com. This website also contains calculator for finding the GCD of 2 numbers, and also for finding the GCD of an array of numbers of more than 2 numbers. Okay, you can have 10 numbers, and the calculator in this website will solve it. It will find the GCD, it will find the LCM, also the least common multiple. So we also, in that video playlist, we talked about factors and multiples in that video playlist. So it is, like I said, it is highly recommended you view those videos in order. That way you get a good concept of this topic, modular arithmetic and algorithms. Okay, so we're going to solve the questions using prime factorization method. What is prime factorization method? Okay, what is prime factorization? It simply means break the numbers, break them into a product of prime numbers. Break them into a product of prime numbers. In other words, prime factors. We want to find the factors of those numbers that are prime numbers as a product of prime numbers. That is simply what prime factorization means. It means factor that number into a product of primes. Okay, we can say product of primes or product of prime numbers. Or just say factor that number into prime factors. into prime factors, okay, product of prime numbers. That is simply what it means. Factor or break down that number into a product of primes, of prime numbers. So, what is a prime number? You know, in arithmetic, we talked about prime number. We say 1 is not a prime number. Okay, 1 is not a prime number. 1 is not a prime number. A prime number. Now, you at least you note this. You note this. Then you now say, okay, prime number is a number that can be divided by only itself and by 1 without a remainder. Okay, so with a prime number, the only thing that can divide a prime number is that prime number and also 1. The only thing that can divide that prime number without a remainder. If any other number divides that number, okay, it will have a remainder. So a prime number is a number that can be divided by only itself and by 1 without a remainder. If any other number, if it's divided by any other number, it will have a remainder. That's a prime number. And you know, it's a very important topic in number theory, in discrete mathematics. Prime numbers is a very important topic. And you know, you could win an award, you could win a prize if you find the highest prime number than what is achieved right now. Okay, so if you can find the highest prime number than what is obtainable right now, you could win a prize. Just read about it. Just read about it, because somebody from United States just won a prize. So you can read about it. So prime numbers is a very important topic, and you know, it's infinite. You know, we have an infinite number of primes. Yeah, but let's get back here. So that's what prime factorization means. Break down a number into a product of prime numbers. So when we have, if we're going to start with two numbers, okay, if we have two numbers, we factor it into a product of prime numbers. We just get the GCD, you know, we can get both the GCD and the LCM right away. So I'm going to write this here. Given, let's say we have two numbers. Let's call it C and D. C and D. Such that C is greater than 1 and D is greater than 1. Okay? We have two numbers such that C is greater than 1, D is greater than 1. Okay? To find, what do we want to find? We want to find, and this applies to, with the prime factorization method, it applies to more than two numbers. But let's begin with two numbers. Okay? We want to find the GCD, greatest common divisor, and the least common multiple. Okay? We talked about this in that video playlist, factors and multiples. Okay. What I find the GCD and the LCM of the numbers of C and D. Okay, of C and D. Right? So let's say, so the first thing you want to do, steps, prime factors of C and D. Okay, say the prime factors. Say the prime factors of C. Say the prime factors of C equal to, let's call this P1, okay, P1, and let's call this maybe X times P2Y times P3Z. Okay, let's say we have the where P is the prime number. Okay, where P is prime number, where P1, P2, P3 are the prime numbers. P1, P2, P3 are the prime numbers. Okay, and don't worry, we shall solve problems, we shall solve calculations on this. So, and then X, Y, Z. Do you see the way I write my Z? So you don't think it's 2. Are the exponents, are they, like how many, the exponents of those prime numbers? They are just exponents. Exponents. They are exponents. And let's say that we have D, let's say we have D to be the same P1 times P2 times P3, but let's have it as IJK, LMN, OPQ, PQR, okay? Well, we've used P, QR, STW, UVW, UVW, this case, this time around. Or we can say ABC. You can say ABC. I hope you don't think my B will be 6. C, D, E, F, G, H. Yeah, let's use F, G, H. F, G, H. F, G, and H. So it's still, we want to find the same prime numbers, but now it might be different exponents. Okay? Might be different exponents. So if it's the same exponent, that's fine. It still doesn't matter. So X, Y, Z are exponents. F, G, H. F, G, H are exponents. Are also exponents. So we now say that the GCD of C and D. That's the way we write it. GCD of C and D. Okay? So you have to find the prime factors as this. Product of prime numbers. That's the prime factors. Now, the GCD of C and D will be, let me write half space here. So we say GCD of C and D is P1 gets only one P1, but find exponent, the minimum number between X and F, XF, okay, times P2, okay, P2, the minimum number, raised to power minimum of Y and G, the minimum, times P3 raised to exponent minimum number between Z and H. That's your GCD of C and D. Now the LCM of C and D, LCM of C and D is P1, the maximum number of X and F, raised to exponent P1 raised to exponent maximum number of X and F, times P2 raised to exponent maximum number of Y and G, then times P3 raised to exponent maximum number of Z and H. That's the LCM. And then you can actually check this. You know, you can actually check. You can, if you like want to play with this, you can actually check to see whether you got this right. GCD of C and D times the LCM of C and D should give us C times D. Should give us C times D. The GCD of C and D times the LCM of C and D should give us C times D. That's it. Okay. Let's begin now to solve problems. We have discussed this, so it's time to now solve questions. So question 1. We have find the GCD and LCM of this. GCD of 12 and 18. We did this in that Euclidean algorithm video. Okay? But here we're going to use prime factorization method. And look, this applies even if you have C, D, E. You can have E to be P1 K times P2 J times P3 M. You know, it applies if you have more than 2 numbers. We're going to solve that kind also in this video. Okay? So here we have 12. Now this is the way I want you to do this, so it saves time. You start with 2. You know, if you have even number, it's better to start with 2 anyway. If you have even number, you start with 2. Start with the minimums first. So 12, we know that 12 is 2 times 6, right? And we know that 6, you can also have 2 there. So 6 is 2 and 3. So you have 2 times 2 times 3. Okay? So actually you have 2 squared times 3. So I want us, you know, when in the video we did factors and multiples, we did it the baby steps. You know, we did it the easy way. Now you're taking discrete mathematics and you're in college. So I want you to now pick up multiplication right away. So in this case, we want to separate the boys from the men, right? So the video we did factors and multiples. Actually, that video is for arithmetic folks. That's for the boys. I talk about it. Okay, let me put in this video in this playlist because some people probably don't know what is LCM, what is HCF, what is GCD, what is GCM, greatest common measure. It's the same thing, GCM, GCD, HCF. So that's why I said this. Let me put it there. But what is LCM? What is LCD? It's the same thing. LCM, LCD, the same thing. So I would like you to, let's get this quick because this is discrete math. But if you want, you can still take your time. 12 is 2 times 2 times 3. Okay, so that is 2 squared, because 2, we are dealing with only prime numbers now. Prime numbers. Factor, product of primes. We're looking at product of primes. Those are prime factors. Product of primes that we're interested in. So this 3 is 3 raised to power 1. We can put it 3 raised to power 1, the exponent. And then 18, we know that 18 is 2 into then 9. 9 is 3. So this is 2 times 3 squared. 2 raised to power 1 times 3 squared. Okay? Right? So that's, we now say that our GCD is, the GCD of 12 and 18 is 2 raised to power minimum of 2 and 1 times 3 raised to exponent or raised to power minimum of 1 and 2. So this will be 2. What is the minimum of 2 and 1? It's 1. Okay? Times 3. What is the minimum of 1 and 2? It's 1. Okay, see. We just get that. Provided we have the same prime numbers, then the exponents, we get the minimums of the exponents. Okay? And this is 2 times 3, and that gives us 6. 6. Now, how is that? Cool, right? Cool, right? So that gives us 6 right away. The GCD 12 and 18 is 6. Okay, now, let's go ahead and find the LCM. Let's go ahead and find the LCM. I think you have taken this one down, so we can go ahead and erase this. You take it down. And like I said, this calculator has everything. It has the notes, videos, and calculators. But you can also check your work with that. So, we can now find that the LCM of 12 and 18 will give us 2 maximum of 2 and 1 times 3 raised to exponent maximum of 1 and 2. Right? See that? So that would be 2 raised to power 2, because the maximum of 2 and 1 is 2. 2 is greater than 1. Times 3, maximum of 1 and 2 is 2. So this is 4 times 9, and that is 36. The LCM or the LCD is 36. LCD. That's when you're dealing with fractions. Talk about LCD. Okay? And then guess what? If you multiply, if you want to check this, check here, like I said, GCD times LCM gives you the product of those numbers. So if you do 6, check left-hand side, right-hand side. So left-hand side is GCD of 12 and 18 times the LCM. LCM of 12 and 18. And then our right-hand side is 12 times 18. 12 times 18. Okay? So this will be 6 times 36. 6 times 36. 6 times 6 is 36, 3. 6 times 3, 18 plus 3, 2. 216. Okay? 216. Now, let's do 12 times 18. So we have here 12 times 18, 96, okay, 8 times 2, 16, yeah. Then 1 times 2, 2, 1, 6, 216. Okay? 216. Thank God it worked. Okay? And if you want, you can jump up and touch the ceiling. Alright, folks, let's do the rest of the problems. Now, we will not be checking it because you can do that on your own. Okay, you can do that on your own. But let's do more of the problems. Number 2, we have GCD of 111201. GCD 111201. Okay, so 111 is 2 cannot go into 111. So with 3, 1 plus 1, 2 plus 1, 3. Now, divisibility rules. We have what we call divisibility rules. How do you know if a number is divisible by 3? How do you know if a number is divisible by 5, by 7, because how do you know if a number is divisible by 2? The number has to, it's any even number, okay? Any even number is divisible by 2. Because we are concerned with prime factors. We are concerned with prime numbers here. Okay, so 2 is a prime number, 3, 5, 7, 11, okay? Because like 11 now, 11 divided by 11 is 1, 11 divided by 1 is 11. If there's any other number that divides 11, like 11 divided by 2, it's going to give you 5.5, that's a remainder. So 11 is a prime number. So with a prime number, only that number and 1 can divide it. Okay, that number can only be divided by itself and 1 without a remainder. If that number is divided by any other number, there will be a remainder. 11 divided by 3 will give you a remainder. 11 divided by 4 will give you a remainder. So the only number that 11 can be divided by is 11. 11 divided by 11, 1. And then 1. 11 divided by 1, 11. So 11 is a prime number. Now 9 is not a prime number because 9, you can divide it by 3. And 9 divided by 3 is 3. So 9 is not a prime number. Okay? So with a prime number, it has to be just that number and 1 only, without a remainder. So we are dealing with prime numbers here. Okay? 2, 3, 5, 7, 11, 13, 17, 19. So it will be good if you know, how do you know numbers that are divisible by 2, by 3, by 5, by 7? How do you know? It will be good if you know it, because that will save you time, especially if you're not using calculator. Okay? So numbers divisible by 2, it has to be even number. Numbers divisible by 3, it has to, when you add those numbers, the sum of those, the sum of the digits, okay, the sum of the digits, if it is divisible by 3, then that 3 can divide that number. So 1 plus 1 is 2, 2 plus 1 is 3. 3 is divisible by 3, so 3 can divide 1, 1, 1. Okay, so we have 3. Now please, I'm going to be using calculator here to save time. I'm using calculator to save time. Otherwise, I can do it. Trust me, I can do it with my own. I can do it without a calculator, trust me. But I'm going to use calculator to save time. Okay? So we already know we have to start with the smallest prime number. Start from the smallest primes. Okay, so 2 cannot, because this is not an even number. This is an odd number. So you now do 111 divided by 3. That gives us 37. 37 is a prime number. So this will just be that 3 times 37. And then the next one is 201. 201, this is an odd number. So 2 is out. Now 2 plus 0 is 2, 2 plus 1 is 3. 3 can go into this. So 201 divided by 3, that's 67. So this is 3 times 67. So this is raised to power 1. Raised to power 1. Raised to power 1. Raised to power 1. Raised to power power, or exponent. So if I say raised to power, I'm talking like Nigerian. If I say raised to exponent, I'm talking like American. Power, or exponent is the same thing. Okay, now, you see there's no 67 here, and there is no 37 here. No problem. You can just put this times 67 exponent what? 0. Remember, laws of exponents. Anything exponent 0 is what? 1. Anything exponent 0 is 1. 67. So this is like saying times 1. Just like saying times 1. So I just want it to have everybody. You mustn't do this. You must not. But you know, I'm trying to show all my work, and I understand some people might be, this guy is wasting my time. Well, I don't want some other people to get confused. So there is no 67. I'm going to put 67 here and put exponent 0. And then I'll put 37 here and I'll put exponent 0. So that I have, we want to have prime numbers in both of them. In this case, it's 2 of them. We have 3, we have prime numbers, the same prime number in those 3. Okay? So we now say that the GCD of 111 and 201 would be 3 minimum of 1 and 1. Okay? Minimum of 1 and 1 times 37 minimum of this 1 and 0, okay, of this 1 and 0, 1 and 0, times 67 exponent minimum of 0 and 1. See that? Yeah. But we want to have same prime number in both cases, okay? We want to, so that we can easily use this formula for the GCD and the LCM. Now, some people might skip it, but we really want to, especially if we are finding the LCM. Okay, so we really want to have both prime numbers in both cases. Okay? And then this will be 3. Now, minimum of 1 and 1. Come on, 1 is equal to 1, right? So just minimum of 1 and 1, you just say 1. Okay? In this case, just say 1. That's fine. Times 37, minimum of 1 and 0 is 0, times 67, minimum of 0 and 1 is 0. So this is 3 times 1 times 1, and that is 3. The GCD of 111 and 201 is 3. That's it. Okay? Now let's find the LCM. The LCM of 111 and 201 will give us 3 maximum. Maximum of 1 and 1, okay, times 37 maximum of 1 and 0 times 67 exponent maximum of 0 and 1. Right? So this will give us 3 maximum of 1 and 1, just say 1. Okay, 1 times 37 maximum of 1 and 0 is 1 times 67 maximum of 0 and 1, this is maximum, is 1. So 3 times 37 times 67. Okay, 3 times 37 times 67, and that is 7437, and that's the LCM. And if you do 7437 times 3, 7437 times 3 is 22311. And if you do 111 times 201, it still gives you 22311. See that? Box. Okay? We are going to stop here for today. We've done 2 questions in this video. We are going to continue with the rest of the questions in the next video. Okay? Thank you so much for listening to this video presentation. If you have any questions, please ask. And you have a great